Okay, so let's search for more derivatives. In this case, the function is y equal to x squared times e to the power of x. Because of the little dot right here, I'm gonna have to use something called the product rule. Okay, so product rule. Okay, why again? Because I have x's in front and x's after the little dot. Okay, so that means I need to do my 1, 2, and then 1 prime, 2 prime business that I like to do all the time. Okay. So my first guy is going to be the x squared. My second guy is going to be e to the power of x. Derivative of x squared is going to be simply 2x. And derivative of e to the x, that's the new rule. That's e to the x times the derivative of the exponent, which is 1. Keep in mind that because we're doing the product rule, we're going to multiply 1 prime 2 and 2 prime 1 and then add everything in the middle. So the derivative that we're looking for, the dy over dx, is going to have to be the product of the two corners, 2x with ex, and added to that is going to be the 1 e to the power of x multiplied with the x squared. Okay, and that's pretty much going to be it. There's nothing much to do here except for clean up very quickly. 2x e to the x, nothing to be done there. The only thing I'm going to do is erase the 1 and just write down x squared e to the x here. This is a pretty way of writing the final answer, and that's going to be the solution there. That's it. So let's take a look at the next one. The next one has a quotient, so it's going to be a quotient rule. So it has y equals to e to the power of 2x divided by x cubed. Again, because of the little line right here, this is a fraction, which means I need the quotient rule. And just like with the product rule, I like to set it up the same way. I like to have my first, my second, and across from them the first one prime and the second one prime. First is going to be e to the power of 2x, second is going to be x cubed. Derivative of e to the power of 2x is literally itself times the derivative of the x1. The derivative of 2x is going to be 2. And once I do that, I'm ready to do the derivative of x cubed, which is going to be 3x squared. Remember, this is a quotient rule, so we're going to do this with a minus sign. 1 prime 2, 2 prime 1 with the minus, okay? So earlier we had a plus and the product one. This time we have a minus with this one, okay? So here we go. The derivative that we're looking for, dy over dx, is going to be a massive fraction. Then we have to multiply the corners. So the corners are going to be 2e to the 2x multiplied with x cubed, the minus that we get from the quotient rule, and then the opposite two corners, 3x squared multiplied with e to the 2x. Everything is going to get divided by the old denominator squared. Okay, let's clean it up a little bit. This is the same thing as writing 2x cubed e to the power of 2x minus 3x squared e to the power of 2x, all divided by x to the power of 3 to the power of 2. That's the same thing as x to the power of 6. Now, for this problem, I have 1, 2, 3 terms. All of them have x's. This one has x squared, this one has x cubed, this one has x to the power of 6. So I'm going to go ahead and divide everyone. I'm going to cancel or divide out or reduce by an x squared. So how am I going to do this? I'm going to do this by factoring x squared from the numerator. That would leave me with 2x e to the power of 2x. And then I'm factoring the x squared, so the 3 is going to stay, the x squared is now gone, it's factored. And then I have e to the power of 2x, all divided by x to the power of 6. So I'm doing that because all my 3 terms have x's in them, so I can now take advantage of that and reduce this x and that x. And I can divide them both by x squared, and that will give me a simple answer. It will be 2x e to the power of 2x minus 3 e to the power of 2x, all divided by x to the power of 4, because I'm taking out 2 from the top and 2 from the bottom. And that's going to be the final answer for now.